Welcome to lesson 47, where we're going to work with expressions that include geometry. Here are the things to look for that demonstrate mastery. Watch them as I do the same problems. You're going to see how we select and write correct formula for the problem. Watch how we substitute the dimensions given and simplify the expression that we can solve for the unknown dimension in the problem, and then check our work with substitution into the original formula with all the dimensions. So these are the things I'm going to do, and these are also the things you're going to practice as well. And by the time you get to the exit ticket, look to see how accurate you are on these 4 criteria. Let's jump into the very first problem. A rectangular garden sits next to a house. 3 sides of the house are fences, and the 4th side is the house. The length of the garden along the house is 9 meters. The area of the garden is 118 and 8/10 square meters. Find the width and solve the equation for W. So basically they want to know what is the width of the rectangle when given the area and the length. That's basically all they're asking there. But they gave us a lot of facts. We know the garden is a rectangle, so we know its shape. We know the length, and we know the area. The width is the part we don't know, and we know the area formula is length times width. So here's going to be my plan. We're going to create a visual representation, which is just a good practice for any geometry problem. We're going to select the formula, which we already know it, given that it's a rectangle, and we're going to substitute those known values into that formula and simplify to find the unknown dimension. In this case, it's going to be the width. So our unknown variable will be the dimension we're trying to figure out. Hit pause so you can jot this down into your notes. We're going to start our plan with our visual. So here's the garden. It's rectangular. And we know the area is equal to 118 and 8/10 meters squared. We do not know the width, but we know the length is 9. So we have that information. The thing about the house, honestly, being on the side, extraneous, meaning it's extra. I don't really need it to solve this problem because I don't need to know the house is there in order to find the width of this. What we are going to do next is we're going to write down the geometry formula for area. We're going to use our EE skills to find the width. So we know area is equal to length times width, and this is for area of rectangles. And now we're just going to sub in what we know. We know the area is 118 and 8/10. We know the length is 9, and we don't know the width. So that's going to stay there. We're going to rewrite this equation. So if 9 times a number makes 118.8, well, I know 118.8 divided by 9 will also give me that number. That's all we're doing. We're rewriting it so that now our unknown is at the end of the sentence, and this looks very familiar to us. Now we can figure this out. I'm not going to use my calculator. I'm actually just going to do the math. Put my decimal right on top so I have it. 9 cannot go into 1. A 9 goes into 11 one time. It's 9. 11 minus 9 is 2. My brain was going too fast, so I have to slow myself down. 28. 9 goes into 28. 3 times. 3 times 9 is 27. And 9 goes into 18 2 times. And notice how, again, there's a digit on top of every digit. And even my decimal is already there. So I already have 13 and 2/10. So 13 and 2/10 is equal to the width. We're going to write that down. The width of the garden is 13 and 2/10 meters. And done. So jot this one down, Math Marvel. I love how for geometry, especially since there are tons of equations, sometimes having a visual really helps. And we could always use our reference guide to find different formulas. But area of rectangles we've done since we were young. Let's jump into the second problem. A triangle has a height of 2 4/10 centimeters and an area of 6 96/100 square centimeters. What is the length of the base? So basically, what is the base of the triangle when given area and height? We know the shape, we know is height, we know the area, we don't know the base. I am also going to give us from our reference table the two different area formulas for triangles: base times height divided by 2, or 1/2 base height. We're going to do the same things as the first problem, create a visual. We're given a formula to work with, and you're going to see how I decide which formula I want to use. We're going to substitute for the known values, dimensions we have from the problem, and we'll simplify to figure out the unknown variable, which in this case is the base. Hit pause so you can jot this down into your notes. Alright, we're starting the same way. I'm just drawing a right triangle here, and we know that the height is 2.4 centimeters. We do not know the base, so lower B, but we know the area is 696 centimeters squared. So if you look at your reference table, there are two formulas for area of triangles. Just a little triangle there. Usually we see base times height divided by 2 in fractional form, or you might see area is equal to 1/2 base height. Either one of them will work. As always, we can represent numbers in different ways, but we want to make sure that it's in a way that's most helpful to us. So I'm going to just substitute both with our numbers and make a decision about which one I'd rather use. So here's 6.96 is equal to, we don't know the base, we know the height, divided by 2. And so just looking at the form of that, there's a lot going on, even though there's just multiplication and division. Versus here's our second one, 1/2 times, we don't know the base, but we do know the height. I'm going to make a determination. I would say for us as 7th graders, we probably want to use this one. This is the one that is more friendly for us to use, for us to simplify. It's not that this one on the left is challenging. It's just that this, I would probably want to do our multiplying by 2 first to somehow get rid of this. And that's something that could be a lot for us to think through. So I'm going to use the one on the right. And I'm just going to shift some numbers around. So I'm going to put the 2.4, and I'm going to put it over 1 on purpose so that I can multiply those two fractions together. And I'm going to get 2.4 over 2. Put a B here. And I'm taking my time with this because there are so many little places to make mistakes. And I want to simplify that 2.4 over 2 again. So 2.4 divided by 2. We can do this mentally in our brains, but just so you can see where I'm getting my 1.2 from, there it is. So 6.96 is equal to 1.2 times the number. We're going to rewrite this. I want the number by itself. So 6.96 is equal to 1.2 times B. So I'm going to turn this into a division problem. Divide both sides by 1.2. So 6.96 on your calculators, you would just use a division symbol and you would get 5.8. So B is equal to 5.8. What are our units? Centimeters. The base of the triangle is 5.8 centimeters. Not centimeters squared, because this is not area, it's just the length. But again, major takeaways just walking through this. I used a visual. I made a decision about which of these I wanted to use, and I chose the area formula with the 1/2. I thought that would be simpler to use. And I'm taking my time. I'm substituting first, and now I'm just simplifying the expression. And now at the very end, I rewrote it to a division problem. On my left side, this just leaves me with b because a number divided by itself is just b. And this was all I had to figure out with my calculator. 6.96 divided by 1.2 give me 5.8 centimeters. So you're noticing that a lot of our problems are going to be bigger. Sometimes we're going to have to use calculators. I like having it there just so we can confirm our numbers because it is a tool and we want to make sure we know how to use it correctly. And there really isn't a reason to have an error in calculation if we have a tool available to help us. So that's it for today, Math Marvels. I just want you to see our process. My last bit of advice to you during this practice, take your time. There's no value to rushing through and being done first. It's just going to be more effective for us to take our time and really know how to do it correctly than to rush and make silly errors, especially on tests. So that's it for today, Math Marvels. I'll see you in the next one. Bye.